Thanks for coming. Today I'll talk about metrics-based voting, which is a new voting mechanism we've developed over the past month. We is the GovXS team. Quick introduction. So I'm the founder of the Token Engineering Academy, and at the Token Engineering Academy, we built a curriculum on how to design, optimize, verify token designs, incentive designs beyond governance. This group, GovXS, met at TE Academy, and we are focused on decision-making systems, DAOs, governance, and it's a nice combination of academic researchers, Nimrod Talman, Eyal Bremen from Ben Gurion University, and Angela, myself, and Muhammad, crypto natives, token engineering, and simulations, verification. All right. I'd like to talk about funding mechanisms today, and you probably all know all the various ecosystem funding offerings, so setting up funding pools for supporting growing projects, building on a protocol, and thus grow the value of the protocol has become something of the gold standard in ecosystem growth. 850 million OP tokens in the Optimism network dedicated to retro funding, which is dedicated to growing the network. This was, by the time of announcement, 3.3 billion USD value. Polygon, 1 billion Polygon tokens equivalent was 640 million. Arbitrum's gaming ecosystem growth program, 200 million Arbitrum tokens equivalent, I think 190 something USD. And also in Polkadot 2023-24, there was this decentralized futures grants program with 20 million USD allocated in 5 million DOT tokens, and since May, a new program running with 30K per developer team at Polkadot as well. So I guess we all know these programs. These programs are really about significant amounts of money, and there are issues. Yes, funding ecosystem growth is definitely super important to grow network value, but currently, any decision-making system has also issues. So if we have grants councils, we still might have voter bias. We don't know exactly on what information voters are making decisions on. There are popularity contests. There might be collusion, tit for tat, between projects receiving funding and voters, or generally a lack of expertise in decision-making. All right, and metrics-based voting is, in a nutshell, ecosystem funding based on measurable value add. All right, how does this work? Let's take a look at this diagram. On the left, we have data, and on the right, we have voters. And these two are coming together in one voting outcome. If we look at data, think of metrics like TVL, token value locked, or active users, or developer engagement. Think of, we are discussing to select projects, building on a protocol. We can measure their contribution to TVL, their active users, their developer engagement to get a picture of how successful they are today, they are in the past, or draw conclusions how successful they might be in the future. Now, with TVL, of course, there are many details that have to be defined, like it's TVL at a certain point in time or over the past 100 days. Is it in native token value or is it in USD value? For active users, we can look at unique accounts. I mean, wallets are anonymous, so unique accounts or proof of personhood that addresses events producing a state change, so we have to further specify how to count active users, developer engagement, for example, on GitHub users, also their trust score in terms of minimum, active month, etc. And this combination of metrics and their specification is what we call evaluation algorithms. On the right hand, we have voters, their preferences, and a voting rule. Let's dive in. Voters vote, in this case, on a metric weight. So they don't vote on projects anymore. They vote on how relevant a certain metric is in the context of a protocol and funding goal. We have to define how to aggregate these votes, because decentralized decision-making means we have many voters, how to aggregate them. And I'll show in a moment that aggregation has an impact on a mechanism. Then adding a quorum, normalization, caps are also part of this right side, how to count and reflect preferences in metrics-based voting. Some more details that have to be considered here as well is the metric weight, so how to decide what relevance a certain metric has for funds distribution in a voting. Aggregation means, is it about a single winner metric? Is it a combination of metrics? Do we aggregate by mean, by median, quadratic? More rules to consider here. Adding a quorum means, is there a minimum of votes or a percentage of votes required? Is there a predefined funding amount, a minimum maximum allocation? And these sounds like details. They are more or less not so relevant, but they become relevant. In total, this design of this right side, the preferences, is what we call a voting rule. All right, we have evaluation algorithms and we have a voting rule. And in practically, this can look like this. This is a screenshot of Optimism's round 4, a voting prototype where voters have been asked to vote on a certain metric, and then they have slider-style inputs to define the relevance of TVL per project, of transaction count, of gas fees generated, monthly active users. So the voters defined how relevant metrics are for the actual funding distribution. So I guess you get the idea. And as mentioned, Optimism implemented this almost a year ago, first time. And in their most recent funding round, they rewarded on-chain builders and dev tools, again, via metrics-based voting. Cryptoland is implementing it and rolling it out, while in academia, this is a brand new challenge. This is uncharted territory. So we have game theory, we have computational social choice. No one so far did fundamental research on metrics-based voting. Nice design challenge, nice research challenge for us. Just on a side note. If we look at the design process, and this is important to be kept in mind for considering metrics-based voting, we have new steps and infrastructure needed. So first, we need objectives to better understand what metrics might be relevant and helpful to take decisions in metrics-based voting and what data sources we need. Then we take further steps to derive an evaluation algorithm, just like I mentioned. If it's TVL, do we measure a certain point in time? Do we measure in native tokens? Do we measure in USD value? The voting rule is this right-hand side. How do we aggregate the voter preferences? Then, ideally, you take steps to validate and optimize, and then infrastructure has to be set up. So we need raw data, on-chain data, off-chain data. We have to aggregate it. We have to understand what granularity we need, real-time data per month, per day, per hour, per minute, per second. We have to also understand how to make these metrics robust, because any metric can be gamed. How to protect the system, and then ongoingly monitor and optimize. And this is what I'd like to introduce now. Metrics-based voting is a really cool paradigm. But how do we know we found a good design? And the beauty of crypto is that we build it, we roll it out, and we already have data available to better understand what makes a good design. Let's take a look at this. I call this strategic implementation. So you are not done if you roll it out and you have a tool at hand. You are done if you have tweaked it and optimized it in several rounds where you test this in reality and then understand how robust is this against attacks. Does the final allocation meet our intentions? Or do the metrics reflect positive impact well? And I guess if someone proposes, like myself, metrics-based voting to you, you might ask the same questions. Okay, number one, how can we analyze how robust metrics-based voting is against attacks? And here we can use complexity analysis. We take a look at the voting rules and can compare different elicitation methods that will have an impact on the robustness, how easy it is to manipulate the outcome. What is elicitation? This is selecting a single metric or a whole set of metrics, or assign weights to metrics. Remember this interface for voters. And for the attacks, we ask how easy it is to manipulate the voting outcome as a voter, bribing other voters, collusion, or even as an actor with control on the metrics to be voted on. So we take a certain part of the voting, derive a formal model, like a certain attack, in this case manipulation, formulated in a formal way. And in the case of manipulation, we ask, can someone change one single vote, a single voter, to reach a specific outcome? And comparing 4 different elicitation methods. Fractional voting is you assign weights, the slider version. Cumulative is, again, the slider version, but you end up at a certain amount or predefined target. This is this typical, how many of 100% would you allocate across metrics. Approval voting is you either say yes or no, and plurality is you say only yes to a single candidate. So these are 4 of many more elicitation methods, and we can analyze them, how vulnerable they are when it comes to a manipulation attack, for example. So this is a table that goes over other attacks as well. If you look at manipulation only, we see that in 3 of 4 elicitation methods, manipulation can be successful in polynomial time, and approval voting is much harder to attack, meaning it's also more robust when it comes to trying to manipulate the voting outcome. So this is one form, complexity analysis, to better understand how vulnerable a mechanism is. And here the result is approval voting would be most robust in metrics-based voting, meaning you would have to choose one metric or say yes to metrics and no to others, and no weighting. And this would make the voting harder to attack. Okay, this is one strategy to verify if a design is good, if metrics-based voting is good. Now, I'd like to take a second perspective. Does the final allocation meet our intentions? And here, as I mentioned, we can even use real data. I pulled the data of the Optimism Round 4 grants allocation, where we had 230 projects being rewarded with a total of 10 million Optimism tokens in this single round. By the time of voting, this was an equivalent for around 25 million USD, so significant. And I took the real allocation and compared it with alternative aggregation methods. In yellow, a medium without applying the minimum and max caps that the real allocation had. So the minimum cap was any project needed, I think, a minimum of 1,000 OP as a voting allocated. Otherwise, it was redistributed. And the maximum cap was 500K. Okay, alternative number 1 is the median, and alternative number 2 in red was mean allocation. And now let's take a look at the deviation, or how this differs. So the diagonal line, the dotted black line, is the real allocation, and only with slightly different allocation methods we end up with different results. And in this case we see that in fact both alternative methods produce slightly lower outcomes in funding allocation than the diagonal real, but in some cases, at the upper end of the results, we see a huge deviation, lower allocations. We can take a look at the numbers as well. These are the top 10 projects. And you see the black bar is the real allocation, and the red and yellow bar are the alternative allocation methods. And again, at the upper end of allocation, there's a huge deviation. And in all others, in fact, the real allocation is slightly higher. Now, this is just looking at the numbers, but for projects, this makes a real difference, right? So again, the top 10 allocations, the alternative methods would have allocated to the top 2 projects up to almost 1 million more. And for any project, this is a huge difference, isn't it? And vice versa, if we look at the first column, look at the 8th project, they would have received less even in a mean aggregation. This could be due to outliers in the metric values, for example, where a median is just removing or reducing the effect of outliers. My message here is, while it is more, let's say, a numbers game, choosing one or the other allocation method for projects and how happy they are with your ecosystem funding and how happy they are and how successful they are to grow the metrics you are aiming to grow, it makes a real difference. And looking at these deviations, what do you think, what's the root cause of this deviation between the black and the real allocation and the alternative methods? Any ideas? Just shout. Okay, the root cause is just this minimum and maximum cap. So that we had a minimum of allocation that was required to be considered at all, and a maximum cap at 500K. And this decision to apply a cap is usually, or is very often, a decision made very swiftly in defining the general setup of a funding round. But it can have huge implications for the outcome and mid to long term for what projects you'll be able to attract and how happy they are building in your ecosystem. And ultimately, how much they can contribute. Again, deviations of 1 million. All right, so the voting rule has a huge impact. It has an impact on the robustness of against attacks, what's the decision for the voters to make, and the final allocations. And sometimes very tiny decisions can have a huge impact, not only in metrics-based voting, but here, certainly, they have. The final question that I'd like to present is, do the metrics reflect positive impact well? Because for any funding decision, we have objectives to meet. And in in many ecosystems, we try to understand what's a positive value add, what's a positive impact on the network value. Optimism ran a retrofunding experiment where they asked, can evaluation algorithms, this metrics-based voting, catch what the community deems to be valuable? And they not only ran a voting based on this metrics-based mechanism, they in parallel asked experts to assess projects. And they have chosen, number one, via the voting in this metrics-based voting process, voters, so any token holder, was asked to decide on or to select the distribution and metrics evaluation algorithm. And in parallel, experts, so 30 community members that have been randomly selected by GitHub Trust scores, were asked to evaluate 69 projects in a pairwise comparison. And the output was a ranking of this pairwise comparison. And of course, for the actual retrofunding round, we also can derive a ranking. Now, they have been running an analysis to compare the results. And here are the results. This analysis was done by the number nerds, Christian. And we can find that if we look at the blue bars that represent the ranking based on experts, on their opinion, and the red bars is the ranking based on the algorithm, so the metrics-based voting they have been running in round 6 and 7. And we can find some very significant differences. Let's focus on two. Use Canon. This is a tool that a DevOps tool supports in smart contracts deployment and customization. And Solhint, this is Solidity linter, helping to cleaning up your code. These are the tools we are talking about. And the expert ranking ranked use scanning significantly higher than the algorithm. And vice versa for Solhint, the expert's ranking was lower than the algorithmic evaluation. All right. Here's the details how the evaluation is, the algorithm is structured. And what I guess we don't have to go over the details, but what's important to understand is the algorithm measures TVL, users, fees generated. And if we'd like to reward dev tooling, which was the reward focus in this round, we can't directly measure users or fees generated. So we take on-chain builders, successful applications built on Optimism, their developers, and what developer tools they use. And there is an OpenRank implementation that they have been implementing to derive the metrics and basically come up with these evaluation metrics. So a pretty sophisticated method. Now, if we look at the final outcome of these two projects that I've picked with a huge difference, we see that this Canon, the DevOps tool, received 30K Optimism, while they have been ranked by experts on position 3, very high. And Solhint received 160,000 Optimism, while they have been ranked by experts on position 10. So this doesn't feel balanced. And there's one pointer you can find at the lower end in the numbers where we see the fees generated. And we have 1,000 and something ETH generated in gas fees by Canon, and Solhint 10K ETH. So 10 times the fees generated. And this is pointing in the direction what an algorithm do or does in this case, and what experts do. And if we look at this analysis, then we can better understand that experts rank projects and how much funding they deserve based on their need. And some experts have a very particular need, and this is addressed by a certain tool. So they think this tool deserves a lot, and maybe it makes total sense. And on the other hand, the algorithm allocates funding across the board, what's generally useful in terms of user numbers or fees generated. And I think this applies to many experts versus algorithmic ranking. And if we are now discussing LLMs and AIs and machine learning models, I think it's helpful to run this comparison to better understand what direction we'd like to take. And there are good arguments to say, okay, we don't care about tools that are particularly relevant for a really small portion because we want to drive generally fees consumed. This is legit. On the other hand, an ecosystem might focus on particular tools that they find relevant and they trust it will mid-long term be really significant for growing the network's value. Overall, I think for metrics-based funding, it has a huge potential for better data-driven funds distribution. It definitely requires new infrastructure that is fit for purpose, and developing and setting up this infrastructure and also making it robust against gaming the metrics requires investment, and changing the evaluation algorithms is certainly harder than changing a voting design just by announcing this should be the criteria, and then you let voters decide with no insights on what data they take into account. But I consider it rather a feature than a problem, because any community, any funding program has to really think carefully about what they'd like to achieve with their ecosystem funding. And they have to not only discuss it, but specify it very carefully and then even express it in numbers. And I think this is valuable for any ecosystem when it comes to funding programs and how to spend billions. And defending against attacks, of course, should be part of the tool stack in place. And generally, the key innovation of metrics-based voting is that we have clear and transparent decision criteria. This is relevant for voters, and this is relevant for projects aiming to contribute to the value. And then they can prove how much and how far they contributed to the value and get a fair support and compensation. And second, we can scale decision-making. Imagine taking this preference side is something that tends to be more stable. So what matters in our ecosystem, how we measure a positive value add, is something that I wouldn't expect to change week by week, or at least I would be concerned. So it's probably something that remains stable and requires, let's say, 6-month, 12-month voting cycles. While on the other hand, the project's achievements might change very dynamically. And a project might be held back in what they are able to deploy in Q1 and have achieved huge success and a huge value add in Q2. And this should be reflected when it comes to funding an ecosystem and support projects and applications on top of a protocol as well. And this separation allows to scale decision-making more efficiently. And last but not least, this asynchronous coordination allows to measure what's going on in our ecosystem. We can apply statistical tools, we can apply analytical tools to ensure that the system, the whole decision-making, adapts to changes and increase the resistance in gaming the metrics. And it makes the model and the mechanism well-suited to what we'd like to achieve. We'd like to be very dynamic, to adapt to the outside world, to attract talents, to attract great teams, while at the same time don't want to overburden in the voting. We'd like to have experts, we'd like to have educated decision making, and metrics-based voting is a big opportunity to combine both. Thank you.